week with me. So for the very beginning part of class, I know I received a few questions since last class. If there are any issues that you have either with Onshape or with the last demonstration that we did in class last week, which was that little gasket, let me know. We can take a moment to address things as a group. Hopefully right now you can hear me fine and see everything. But if that ever is not the case, just speak up. All right, so if everyone is fine, we will start with the day for today. As usual, please ask me questions if you ever think. Sorry, I'm not sure if someone was saying something, but if you ever have any questions, please let me know in the chat or by saying something, as I really do appreciate your feedback in knowing how fast I should go, what I should try to cover. So yeah. All right, so when we left off, we had covered kind of our sketch tools. So all of these tools. At this point, hopefully you all remember basically how to draw shapes in a sketch. You have your line tools, your square tools, and your circle. These are the ones that we covered last week and made something with. The other very important thing that we covered was these constraints. So hopefully you're all comfortable now with making lines horizontal, perpendicular, and making things coincident with each other. And so take this time, if you haven't already, to start up Onshape, make a new document, or use your old one, and we'll get into some new topics for today. And so first question I have for you, it's a bit of a philosophical one. How would you model a sphere in CAD, in Onshape, knowing what you know so far? Any ideas? Any tools that you might use? I do see a question in the chat. I'm not quite sure what the four square refers to. Or perhaps you mean like the view that I have right now. You can pan around with right click, and you can click one of these to align your view. Any ideas on the sphere? Maybe a tough question. Perhaps what you have learned so far won't quite get you there. Yeah, a bunch of circles is a suggestion. And so that is exactly what we're going to do. And in trying to make a circle, we'll hopefully show you some interesting things. So of course, when we're trying to make a rectangular prism or a cube in 3D space, we were starting out with kind of the cross section, which is a square in 2D. And so it makes a lot of sense to start with a circle. And I see what the suggestion in chat is kind of making a bunch of circles, like slicing for a 3D printer, which is a great idea. Doing that would produce something like a sphere, maybe. But what I want to demonstrate is that there's a bit of a trick question. With the tools that we've gone over so far, it's not really enough to make a sphere. I can start off with a circle like I did for the cube or the rectangular prism. And if I go to my extrude and you'll see that what I get is not really a sphere, it's a cylinder. And even if I tried to make one, let's say with this idea, I made a series of very thin circles and I drew another circle on top and on top, it still wouldn't be really a perfect circle. And so hopefully this convinces you that the extrude tool is not enough for our purposes. We do need to use some of these other tools to model anything that we might want to. And what I'm going to introduce to you to achieve our first problem of making a sphere is the revolve tool. And you can see when you're in your sketch tools, they also show you two 3D tools. One of them is extrude, the other one is revolve. So it's very important. And we'll get right into it. So what I want you to do is just on any plane, create a sketch, create a circle. And what I want you to do then is to create a diameter of the circle. So you can go to your line tool, hover over the top center of your circle, make sure it turns orange, click once here, and hopefully it'll kind of snap to knowing that you want the diameter. If you click on the right spots, it'll do it automatically for you. If not, hopefully you're able to use what you know about constraints to tell it that you do want it to be the diameter. And having done that, you can accept that sketch. And we're going to take a look at our second tool, which is the revolve tool. So just like the extrude tool, you can click it once to pull up this window. And in this window, you can see it's kind of similar to the extrude tool where it asks you to select a sketch region. And that's the same kind of thing that you can select for an extrusion. In my case, I can just click on this part of the circle. And now there's something different. The revolve feature asks for two different selections, the second one being what they call a revolve axis. And you can imagine what that will be is to define your revolution, you need to tell Onshape about where you want to turn this region about. And maybe that'll make more sense once I actually do it. The way I select one is to click this box here that says revolve axis. And this line that I just drew in the middle of the circle, that's what I want it to be my revolve axis. And once I select that, you can imagine that this sketch region, this half circle that I selected, is being rotated around this line. And when it's swept out, that half circle will sweep out a sphere of volume. And so that's what I end up with. Just to show that one more time. You want to use your revolve tool. Select one of these semicircular regions. And using the revolve axis selection, you click that line and you'll get a sphere. And so now that you know these two tools, you're pretty solidly equipped. You can model many more things than you were able to before. And for a moment, I'll just go back. I'll start with the sketch. So I'll just say that one more time since it seems like there are a few questions about it. Once you're in your sketch, you want to have your circle. Use the dimension tool to call out the diameter of the circle. I just picked an inch. You'll notice for some reason it's not blue. I can figure out why it's not blue by dragging it around. Oh, the center of the circle is not constrained. I can select these two, hit coincident, and now it's black. And now to do the diameter, I'll want to go to my line tool, and for my circle, if I hover at just the right spot right here, you can see these two constraints show up. On the left, there's kind of that crossing lines symbol. That's the coincident constraint. And to the right of it, you can see there's like a vertical line, and that's the vertical constraint. So if those two appear, that means Onshape understands what I want it to do. It'll create those constraints for me automatically when I just click. And I can do that again at the bottom, make sure those two constraints come up, and I can click again, and it'll turn black. That's the diameter. If for some reason, maybe I miss, my accuracy is not great, I get something like that, or let me make it even worse. If I want to make a vertical diameter and I just drew something like that, I could still turn this into the correct thing that I want just by using the coincident constraint to make these points touch the circle. Then I know I want the vertical constraint. So I make this vertical. And finally, I can do another coincident constraint just to make this point coincident with the diameter. And that's geometrically enough to tell it which line I want, which chord, if you like your geometry. Hopefully that cleared up the question about that diameter definition. The other question was how to define or how to select the semicircle. When you select once you approve that sketch, you click that green check mark, it'll be back to your 3D tools. If you hit revolve, the first selection that it asks for is a sketch region. So having created that circle with a line through it, the two regions that it'll automatically identify are these two semicircles. So you should just be able to click one. If not, we can take a look later. But you do that, you select the center line, and hopefully that'll work out for you. What we'll do next is a bit of a spatial reasoning question for you. What if instead of revolving around that diameter, what if instead I did a revolve about this line? So let's say that I just have this line here. It's not fully dimensioned, but don't worry about it. It's just a demonstration. I know some of you have seen this before, maybe, but if you have not seen this before, if I take this sketch region, which is now a full circle, and I revolve it about this axis, what shape am I going to get in 3D? Any guesses? A ring? All right. Yeah. So it seems like you have some pretty good spatial intuition there. And we can find out pretty easily just by doing another revolve. We select the sketch region again. We select our revolve axis, which is now this line. And what we get, you see, is this kind of torus shape. It can be a ring, a donut. And so you can imagine that to do this with just extrusions would be quite difficult. Still possible, thanks to certain other tools that we'll go over today, but not as easy. So that's just about the last thing. There's just one more thing that I want to impress in you regarding the Revolve tool. And that's that sometimes you can achieve the same task using both the extrude feature and the revolve feature. And it's up to you as a designer to be smart about which one to use, because it can make your life a lot easier or a lot harder, depending on which one you choose. So yeah, for the donut, I see there's a question about that. The way you go about that is to just make a circle, make a line that's not within the circle as your axis of revolution. And you can imagine by rotating the circle about a line that's outside of it, you can get some kind of you can get a kind of toroidal shape.
Oh my god, làm sao mà chụp ảnh?
All right, so
Okay.
the other thing I guess that I was going to say is, let's say you're trying to make a structure like these cakes here, where you have a cylinder stacked on a cylinder, stacked on a cylinder. And so as you start working on CAD and projects, like for your robotics teams, and other people are going to be working with your CAD, it's very important that you design things in such a way that it's easy for other people to update and understand what's going on. It's a lot like coding, if you have experience with that, where you just want the structure of your feature tree to make sense to other people. And so one approach to making that kind of cake structure would be to start out with a cylinder just by extruding a circle. Then I'd go on top of that cylinder. I would sketch another circle. And so on. You can see where I'm going with this. But you can see as I do this, I'm cluttering up my feature tree with all these sketches and extrudes. Every time I have a layer, I'm going to have another sketch and another extrusion. And it's not really as robust because whenever I want to change the overall shape of the cake, I have to go back through each and every one of these sketches, make my adjustments. And so there's a lot simpler way to do this. And that is to create one sketch and one feature using Revolve. And you can achieve the same geometry as you can see. I won't stop to fully dimension everything for the sake of time, but you can see that now in my feature tree with just one sketch and just one feature, I've created basically the same thing that I wanted. And so hopefully that motivates you when you're making things to just ask yourself, is there a cleaner, easier way to do this? Because very often there will be. So if there are any questions about revolves in general, the new things that we've covered, or just a general Onshape problem, I'll pause for a moment to let you ask. But if not, we'll move on to the next topics. Great. Just as a heads up, in the middle of the class, so we started at 6:30, at 7:30ish, I'll give you a short break. And during that break, if you had any questions, I know some people emailed me about things. I'll be happy to work with you individually on those. So at that time, just feel free to ask me. I see a question about the cake. So yeah, the main lesson of this, don't worry too much about making this yourself, but whenever you come across a design requirement where you have to make this kind of rotationally symmetric tiered cake type of object, maybe not a cake, but like maybe for a robot, for your drive shaft or drivetrain components, you have like a drive shaft or a hub that's kind of this shape. It's a lot easier to define a profile like this and then to revolve it rather than to create a lot of cakes and stack them on top of each other using the extrude feature. That's the main lesson. Don't worry too much about the specific shape. All right. So we'll get into the next item now. So just create a new sketch. And I'll just make maybe an L shape. Again, don't worry too much about dimensions. this demonstration isn't too involved. I just want you to have a solid kind of shape. So using the line tools, you can kind of trace out an L like that. If you're picky, maybe perfectionist, you can stick some dimensions on there. All right, so once you have a shape like this, you can resolve your sketch, click the green check mark, and just extrude it. Let's say 3 inches. So having made something like this, what I want to show you is these two tools. So after sketch or after extrude and revolve, these two are among the more common ones that you will use. And I'll start with a fillet. So you can open up the tool just by clicking this tool. It's the white cube with the rounded corner. And when you open it, it'll ask you to select entities to fillet. And basically what that's asking you for is to select some of the edges of the object, maybe this one, and this one. And you can see what it does is that it kind of turns a sharp corner into a rounded off corner. So don't worry too much about these settings. The radius is probably the one you'll use most often. And you can see by doing this, both for external and internal corners, I can turn this rectangular shape into a more round shape. So just one more time, in case you missed it, you want to fillet, and you can select edges. I'll select a different pair of edges this time, maybe these. And you can see you get this kind of rounded off shape. The chamfer tool is very similar. It's the one right next to the fillet tool, and you can select edges as you could. And you can see what it does here is it kind of turns your edges into angled bevels. And so there's a couple things to point out about this. The first reason is, why would you do this? And there's a few reasons. The first is that sometimes when you use it well, it can look more aesthetically pleasing, which is always nice. The second might be that when you fillet something, you're more accurately representing how it's going to be manufactured. So I'm not too familiar with how most of you on your teams manufacture most of your robot parts. Maybe there's some that you get machined. Maybe some of it is 3D printing. And so there are always minimum radius requirements for making parts on a machine. And it'll vary based on what the machine is, what the process is, but just due to the limitations of the hardware itself, it's not possible to make an infinitely sharp corner like this ideal square that's modeled here. So let's say for a milling machine, that's the end mill diameter. For a 3D printer, it might be the minimum step of like the stage or the CNC router or the laser cutter. Whatever it is, it's often a good idea just to round your corners off. And the third reason is that when you're designing things, it's actually a bit stronger to have these rounded off corners because it avoids something called a stress concentration, where at these really angular geometries where your part comes to a point, it's actually going to create a higher stress at that point, making it more likely to break starting at that corner. And you can imagine, I can kind of, you can imagine the part might be a bit weaker at that corner. So making the smoother transition between surfaces can help with that. So here's your fillets, use them wisely, and use them in a smart way. You can imagine that if this were my desired geometry, if I wanted to create this L shape with rounded corners, what I might have done instead is, instead of just creating this L, I might have, let's say, explicitly drawn it in my sketch to be round. That's probably the best way to demonstrate that. I might have drawn something like that, right? Generally, it's best practice not to do this. It really creates more of a headache than you need. So if you're ever in a sketch and you're painstakingly dimensioning this little circle just so you can get this rounded L geometry, just do the 3D fillet in your 3D feature tools. So that's your introduction to these two tools. If you have any questions about that, I'll just pause for a moment. And if not, it's also fine. We'll kind of get into the next part, which is leading up to assemblies. We're not quite getting there yet, but let's make a part that we're going to assemble later. And the classic part that we put together is a Lego, like a toy brick. I'm sure you know better than I do. So we're going to model one. We're going to learn a few more tools as we do it, and then we're going to learn how to do an assembly where we take multiple parts and put them together in different ways. So we'll start off we're going for a square brick here. I'll start off with a corner rectangle, and I'll dimension. You'll notice I don't always click the dimension. You can just hit D on your keyboard. And in general, if you're gonna do a lot of CAD, it's good to learn the keyboard shortcuts because it'll save a lot of time. Say I'll make it 4 inches tall, 2 inches wide, kind of a longish brick. I'm kind of looking down on it from a top-down view to give you an idea. And the other thing that these bricks have is kind of those circles. For our purposes, it's mostly just going to be cosmetic. So you start off, just make a center point circle and drag it down somewhere around where you'd want the first one to go. I think that looks pretty good. So I'll dimension it. Again, I can just press D or click the dimension tool. I'll call it 0.5. You'll also note that this is pretty huge. Don't worry about it. So I have my diameter defined, and I want to define the position of it. So the way I can do that is select my dimension tool again. I want to click the center of the circle. And what I'm interested in is how high above the origin and how far to the right of the origin this point should go. So since I'm interested in dimensioning its location from the origin, I click the center, I click the origin, and now I have a lot of options. If I put my cursor kind of down here between them, it'll understand that I want to do the dimension horizontally. And you can see kind of these guidelines. They reflect that because they're vertical. For here, I'd just be dimensioning the radial distance between them. This would be the vertical distance. Again, radial, horizontal, radial, vertical. So I want to do a horizontal distance, which I can do like that. Again, I'm still on the dimension tool. Now I want to do the vertical dimension. So again, I select the center, the origin, put my cursor out here somewhere, and I can type in a number. So after this, we're going to do something big. So if you have any problems getting to this point, speak up in the chat. All right. I see one comment. Yeah, how do I do dimensions like that? Great question. I assume you mean, how do I dimension the center of the circle? So everything is done with this one dimension tool. I know maybe in like some ancient, very old CAD packages, they had explicit dimensions, but every modern CAD package has like a smart dimension tool now. So a single tool, just this dimension tool, can do everything, whether it's diameter, or angle, or length of any kind. So I can click on this outer ring of the circle to tell it that I want the diameter. And then for its position, I kind of want to locate the center of the circle. So still on the dimension tool, I click the center of the circle. I click the origin. And now I have a lot of options. Like I said, this is kind of a smart dimension tool. So all of these dimensions are built into the same tool. I can do vertical dimensions with this tool. I can do horizontal dimensions with this tool. It's very powerful. So I want to do a horizontal dimension. So I just bring my cursor down here. And the way I know it's a horizontal dimension is because this little arrow where it says 0.5, it's kind of covered up by my cursor, but those are pointing like left and right. So I know it's a horizontal dimension. I click once, it brings up this text box. I put in 0.5 and it's done. Likewise, to do the vertical dimension, I click the center of the circle, the origin. I move my cursor until these arrows are pointing up and down, and that's how I know it's a vertical dimension. I click again, text box comes up, put 0.5, and it's done. All right, hopefully that helped. So now if everyone is up to this point, we're gonna introduce something new, something, again, very powerful, maybe a bit confusing at first. So to finish this Lego brick, I just realized perhaps that maybe some of you don't know. I mean, I'm sure all of you know, but just in case, I'm going for something like this. So at the end of this, I'm going to have like 8 of these little circles. So hopefully that gives you an idea if you didn't. And so, as I just said, I need 8 of these circles. I just have one. And just to do this one, it took me all that effort. So how can I save myself a lot of time and not have to draw 8 circles? Right, pattern. Great prediction by the person who typed in chat. So the pattern tool is over here. It's kind of the third one to the left, or the second one to the left from the dimension tool. You can see by default it has linear pattern selected, but the other options are circular pattern. Don't worry about transform, but what we want is linear pattern, because you can imagine it's kind of a grid. Everything is regularly spaced. So I click the linear pattern. Then I click this circle. That's what I want to pattern. And once I click it, all these things pop up. So one more time, I can either click this or do the drop down, click that. And I want to click the circle. So now by default, it assumes I want to pattern in X and Y, so horizontally and vertically. I can change that if I want to do some kind of angled pattern, maybe. I can drag out these boxes. So now I can do whatever kind of crazy pattern I want, but that's not what I'm going to do. So all I really want is to fill this rectangle with circles. So you can see there are these two numbers here. One of them says 1x, one of them says 3x. They might be covered up by some of your other dimensions. You can drag things around so they're not in your way. I'll drag this out of my way. But find one of the boxes that says like a number and x, and you can double click these, type in the number you want. And once you do, that tells Onshape how many instances of this sketch feature do I want to pattern. In my case, I want 4 of them going up. I want 2 of them going to the right. And the spacing by default is 1 inches. I'm fine with that, so I'll keep that as it is. And the way I accept this is just to click on the background. If I left click, you can see the little icon here. There's a green check mark. Once I left click, this will be accepted. So I won't do it for a second, just so you all see what I have. But once you get here, left click, and you'll see that the sketch will be completed for you. Yeah, so let's see another question. So yeah, I'll show that again. So in the top here, hopefully you found the linear pattern tool by now. You click that once. It's not like obvious that the tool is selected. It's not too great on the UI end. My cursor doesn't change, but once this is highlighted, I know I'm in the linear pattern tool. I want to click the circle once because that's what I want to pattern. And it brings up this interface. So by default, it'll look something like this. Maybe yours is a bit different, but that's fine. You want to find these numbers that say X after them. So there's a 3x here, a 1x here. To change these numbers, you double click on them. You can type in a new number. For me, I want 2 going horizontally, and I want 4 going vertically, kind of like this. And these can be clicked, but for our purposes, we're not going to click them. What they do is change the spacing and the angle of the pattern. So you don't need to change that. Once you do this and you left click, it will create the sketch features. So if you need, I can show that one more time, but just let me know. See in the chat, someone has lost some progress. That is the downside of, I guess, like a cloud-based online browser CAD program. But to be fair, SolidWorks is known for crashing a lot as well. It's kind of a fact of life where if you work with CAD, you're gonna have to deal with crashes. So sorry for your loss, but that is how it is sometimes. Yeah, I'll show it one more time. Thanks for the great feedback, because I really don't know what's going on unless you guys tell me. So here I am, I have my rectangle and my circle, and I want to create a linear pattern. So I click on the tool, it'll turn highlighted, and I'll then click on this circle, which is what I want to pattern. So once I'm here, also let me know if a certain aspect of it is unclear, because I'll probably end up saying the same thing again, which might not be as effective for you. So if there is something specific with the demonstration that's not clear, just feel free to tell me. What I want to do is change this number. This represents the instances. So the horizontal instances is 2, because I want 2 of these circles, including the original. This is the vertical instances. So I can double click that as well and change the number this time to 4. Don't worry about the triangle and the square here. Don't worry about these. By default, they happen to be what I want, so that's great. And so if you can get to this, what I did was I clicked the tool, I clicked the circle, I changed these two numbers. I'm not sure what you mean by the markings. Yeah, the arrows are part of the interface of the tool, so I can't really make them go away because I do need them if I wanted to make like a parallelogram type of shape. But once you accept it, and once you like exit the tool, they'll disappear because you don't have the tool open anymore. Like these markings are all part of the tool, so hopefully it's not too much of a nuisance. So once you left click on the background anywhere with that green check mark, you just left click on the background and it'll make this appear. If by markings you meant these, I forget if I went over construction lines with you last week, but I guess I'll take this opportunity as you figure out the pattern. This is the construction tool. Shortcut is Q. It's also extremely useful. And so what a construction line is any line that's not going to become an edge of your part. So often when you're designing things, it's very convenient for geometry's sake to have these extra lines that help you define where things are. Let's say that, forget that this is a Lego brick for a second. Let's say that for this part I'm designing, I need to have a circle right here. And let's say now that this might not be, okay, I'll do it this way. So let's say that for the sake of creating relations, I need to have these lines that I just drew just to locate this. And I might need to do that, let's say, if I needed to define an angle. So let's say I need the circle exactly over here. And the only way I can do that is by creating these lines. But these lines aren't actually part of my part. I don't want these lines to exist when I'm done with my sketch. And so construction lines are kind of a way to show that these lines exist to support the geometry. They're not part of the actual finished design. They're just there so I can use them as a reference when I'm doing things like making dimensions. So these construction lines, you can probably delete them, but if you delete them, it might make the pattern not work anymore. So it's best to just leave them. They won't interfere with your 3D features like extrude. You can't create a region using construction lines. So for the most part, they're just kind of there for you. All right, if anyone has any problems with getting to this point, let me know. If not, I'll resolve the sketch and move on. No, okay, last call. Yeah, here we go. So hopefully your sketch there was fully black, fully defined, no blue points or lines. And you'll have something like this now in your 3D space. So all we have left to do is kind of turn this into an object now. And we'll do that with our trusty extrude tool. And this will be a bit more interesting than what you've done so far because there are multiple regions now. You can see already that I have options on which region I can select. I have 9 options, in fact, because I created 9 regions. And so I'll start out by creating kind of the body, the big rectangular part of the brick. And so to do that, I want to select every region. So I'll start out just by clicking anywhere. And you can see what happens is that I kind of get this like Coke brick with the holes in it. It's not really what I intended, but I can select Yeah, it does kind of look like Lego, but not quite in the way that I will intend. I do want to fill out the entire brick for the first part, so I can do that by selecting the remaining regions. In a sketch, every space that's completely closed off by solid black lines or blue lines, but so any line that's not a construction line, if you have a space that's enclosed by those lines, they comprise a region. So you can imagine that every single one of these circles contains an area. And so that area is a region, and that region is something that I can select. So once I manually click on those 8 circles, they'll also be selected, and I'll have a little cube prism like I did before in my very first demonstration where I extruded a square. So this is what I want. I say 1 inch is fine, and I'll accept it. Hopefully that was pretty straightforward. Nothing too extraordinary there. So now how am I going to get those little studs to come out? You can see what you might notice is that that sketch that I drew, you can't see it anymore, but it's still in the feature tree, which, as you'll recall, is like the list of every object in my workspace. And when I hover over my sketch, you can see it appears again. It's orange, it's highlighted, it's still there, but you'll notice here where this eye icon is, the eye, there's this crossed out eye symbol, and that means it's hidden. So the way I can unhide the sketch is to click on this eye icon. And once I do that, it'll reveal the sketch again. I can see what I was working with before. Sketch is still there, and now I can see it. So the eye icon in the feature tree, that's how you show and hide things. You can also do that with my planes. If I don't want to see those, I can hide the origin, and I can unhide them just by clicking the eyes again. Having done that, I will now realize that it's kind of upside down. So I'll quickly fix that. You can go back into your extrude tool, right click it in the feature tree, hit edit, and it's a very quick fix. If you ever want to reverse the direction in which you extruded something, you have this little arrow here, which says opposite direction. This isn't super important. You can just make it upside down if you want. And in reality, nothing is truly upside down. It's all a matter of perspective, but I kind of want it like this. So I just hit that arrow. You can see whenever I click the arrow, the direction of the extrude changes. And that's also quite useful, especially in assemblies later on, where there's a similar tool for mates. So I kind of want it like this, where the sketch is on top of the block instead of on the bottom. It's not too important though. Just make sure you have your sketch shown so you can see it, and you have your solid block extruded. Once you're at this point, we're just going to extrude these 8 circles. So we pull up the extrude tool once again. We select the 8 circles. And we do that just by clicking on them. If you accidentally click something you don't want to click, like this entire region, I can unselect it either by looking for it and clicking the X, but these all have the same name, so it's kind of hard to tell. I can also just click on the region again, and that'll unselect it, deselect it rather. So hopefully you get something like this, and I'll just make them a bit shorter. That's not quite what I want. And I made them 0.25 inches, 1/4 inch. And after all of that, I don't want to look at the sketch anymore. These lines are kind of ugly. They get in my way. So I can just hide the sketch again just by clicking on its eye. There we go. So from here, I'm going to introduce a new tool, and then we'll go into our break. So this is our call for questions up to here before I show the last step. All right, here we go then. You'll notice at the bottom here, it's kind of blocked off. It's a solid piece, and that's not really very helpful. Oh, I see something. How do I not show the lines? The lines come from your sketch, which is presumably shown. So you can hide it by clicking the eyeball in the feature tree, just hover over it, and you click it, and hopefully the lines will disappear. Yeah, so I'm not completely sure what the question is, but it has something to do with the round parts. So I assume like the second extrude, yeah. So I'll show that one more time. Show your sketch by hitting the eyeball that's crossed out. So if it looks like this, it's good. If it looks like this, then you want to click this crossed out eyeball, and it shows the sketch. You use the extrude tool again. Make sure you kind of like rotate to where you're looking on the sketch, not through to the sketch. Hopefully you can tell the difference. So I want this, not this. And with this extrude, I can actually just select these circles one by one. Just clicking on them. And I'll set a distance, just arbitrarily a 1/4 inch. And that's how I made them. If you accidentally click this region, you can just click again to deselect it. And when you're done, you just green check mark as usual and hide the sketch. All right, hopefully that's clear. Last thing I'll show before the break is just what we're going to do about the fact that there's a solid piece in the way that gets in the way of your, yeah. As I said before, during the break, if you have any questions, we can take some time to go over things. Since we just have a couple of minutes left, I'll just show what we're going to do. We're going to introduce a new 3D tool called the shell tool. This one isn't quite as common as extrude and revolve and fillet, but it's still quite useful when you need to make thin parts. So I'll kind of let the tool do the demonstration. I'll show what it does. So it asks for a face, and I'll just go around and click this bottom face. And once I do that, you can see the bottom of it becomes kind of hollowed out. It kind of follows the geometry of what's on the other side. And it creates a region, let me show you the options again, that has a thickness, a shell thickness of 0.1 inches. So I can make this a bit thicker if I wanted to, maybe 1/8 of an inch. And you can see it gets a bit thicker. And that's all you really have to do. So hopefully by the end of all of this, you have something that looks like this. It's not perfectly accurate, but it'll do for our purposes. So once you're at this point, just keep this. We're going to use it in the next part when we come back, where we'll start talking about assemblies and how you can put parts together. All right, it's a bit early, not quite 7:30, but I'll wrap it up for now. So take like a 7-minute break, I guess. And in the meantime, if you have any questions, we can go over those. So see you later, very shortly. Okay, so I have one person who has a question, and I guess we can go into a breakout room. How about room 5? Seems like no one's using that one.
What time are we coming back?
Sorry, I realized I may have just left too soon. If you do want
Hold
help,
on,
I'll be
let
in
me,
room 5.
Uh-oh. Okay, yeah, what time are we coming back?
I said 5 minutes, or so at 35 is the intended time, but
Okay, thanks.
it's fine if it's a bit longer. And if anyone else has questions, just once I come back, I can also go back and go over other questions. So I will be right or up and to the left. They're actually different, and you can see this way it creates a different colored box in this way. And so this is kind of your standard. You have to encompass the whole thing to select it. And if you drag up and to the left, you only have to select a part of it to select everything that's even slightly intersecting with that box. So this one is more inclusive. You can select everything just by kind of like touching it. And this, you'll see like if I just touch things, but I don't encompass them entirely, it doesn't select anything. Whereas if I did this, it would select everything. Yeah, so that's the difference between those. Then there's scrolling up and down to zoom in and out. Hopefully that's also pretty familiar by now. If I middle click mouse 3, whatever you have as that, you can pan. So for most mice, if you hold your scroll wheel, if you click with it, you can pan. There's right click, which allows you to rotate. So hold right click, move your mouse around, and that lets you rotate. And there's a navigation cube. So that's pretty much all you'll ever need. Hopefully, for those of you who needed it, that's sufficient. And at this point, we'll get into the assembly, which is hopefully very exciting. And we're going to start our basic assembly with these little Legos. So you'll notice here in the bottom tab of your workspace, all along there has been an assembly. You might not have needed it up to now, but now we need it. So you can click it to change tabs, and now you'll be in the assembly workspace. As another note, you'll see there's also a plus sign. And so if you click on the plus sign, you have a few options. You can create another part studio, which is what we've been working in before. This is a part studio because I was making a part. I can make another assembly. And these two, they're useful, but we're probably not going to cover it this class. So in any case, go to your assembly. It looks something like this. It's another 3D workspace with your navigation cube and your feature tree. And what's different about this is that you can have multiple parts in an assembly. So it's kind of like building up. We started with sketches. We have multiple sketches in a part, and you extrude them to make a part. And so now we're in an assembly. We have multiple parts in our assembly, and we can mate them together to tell Onshape how these parts should behave with respect to each other. So the only thing in our workspace right now, in our feature tree, is the origin. And we want to import our block that we just made. So there's, what you can see here is the insert tool. And my options right now, is this Part Studio. So like I said before, Part Studios are where you make parts. Right now I only have one Part Studio and it's named Part Studio 1, and it appears here, Part Studio 1, and I can select Part 1. Once I click Part 1, I'll see this part that I just made. When I click once, it puts it there, and now I have the option to either accept it by clicking the check mark or adding more parts. So in my case, I want more parts. So I'll put another one by clicking this and clicking back in the white screen. And I can just keep doing that for as many times as I want these things. All right, once you do that, you can accept it with the green check mark. And your parts will be ready for you to use.
I have a problem.
Yes.
So when I like insert the part, the bottom part of the Lego brick is not like indented like the ones in my Part Studio 1.
You mean it's not like shelled?
Yeah.
Okay, that's quite interesting. So you're working in the same document, right? You have.
Yeah, same document.
I'd say it might be a visual thing.
Should I
If
try to reload?
I guess make sure that in your part document, it is correct. The shell feature did resolve. It's not red or anything. And if that's the case, then in your assembly, it should be fine. It's probably a visual issue. But yeah, you can reload if you want. If you actually accept it and it turns out not to look the same as in the Part Studio, it's pretty weird. So we can.
Do I have to
look
save
into
it or does it auto save?
Yeah, it auto saves on Onshape.
Okay.
It's a bit like Google Docs. I see there's a question about shelling and about the assembly page. So as a brief reminder, I suppose, if I assume that the person who's asking has something that looks like this with a solid block, the shell tool is in the middle. It looks like this. It says shell on it. It's between like the whole tool, the fifth one, and like the second set. Once it comes up, it asks you to select a face. You select the bottom face, and you can adjust the thickness if you want. You don't have to. You can. That's what happens if you do. And you click the green check mark. So yeah, okay, great. Good to see that's all good. The question about the assembly workspace, all of your different things are kind of in the bottom here. All your part studios, your assemblies. So by default, hopefully there is an assembly. Let's say for some reason there is not. Let's say you just see something like this. You can create an assembly using this plus sign. And the second option here is to create an assembly. And when I do that, it takes me here. Hopefully that answers your question. Okay, great. So now that we're here, we hit insert. We select part 1 within Part Studio 1, which is this. And we can just click, 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 as many as you want. Click the green check mark. And now we're here. So if you have any questions up to here, please ask. Yeah, I see someone says there's this upside down. That might have happened back. You might recall that I made a sort of a big deal about how my thing was upside down. It's not really a huge issue, but what probably happened is that you chose your first extrusion to go up rather than down. But don't worry about it. It doesn't really matter. Yeah. So once we have these things in our assembly, you'll notice that they're kind of free to do whatever I can click and drag them and they move around wherever my mouse goes. And so that's great for now, but as I work towards a design, that's not really what I want. So the first thing I can do is to set one block to be fixed. And the way I do that is I can just right click on the part itself, just hover over it somewhere, right click it. And you can see kind of down here, I have an option called fix. And what that does is it fixes it in space. So now it's completely constrained. Whatever position it's in right now, that's where I want it to be. I'm fixing it. So once I click that, you'll notice that I can no longer freely drag it around. It is where it is, it's locked. If I decide, oh, I don't want that, you'll also see like this icon means it's fixed. It's kind of like a ground icon. Yeah, so that's that. If I ever want to undo it, it gives me the option to unfix it. And when I do that, that icon, that symbol goes away, and I'm free to drag it around as before. So I do want to move it around, but let's say that this assembly isn't my last assembly. Once I make this assembly, I'm going to put it somewhere else. Like let's say there's another assembly that contains this assembly that contains parts, right? And for a very complex system like a robot, where it makes sense to divide it into multiple systems like the frame and the drivetrain, you're probably going to work with sub-assemblies. So it often makes sense to use the origin of your assembly as a logical center of your work. So I do say I have a question about how to fix things. You can right click over the part, just anywhere over the part, right click, and fix is this option here. But for now, we're not going to do that. It is an option and you're free to use it, but I'll show you an alternative. And that alternative will introduce you to our first mate. So you can see all of these tools here. When we were in a sketch, we had our sketch tools in this bar. When we were in our 3D space, we had our 3D tools in this bar. Now we have mate tools when we're in our assembly. And the first mate we're going to learn is fasten. So the way you can think about these, every mate is how you tell Onshape how these different parts will move with respect to each other. So right now I just have this collection of parts that I dumped into the file, but there are no rules. I can move anything wherever I want. And mates are how I'd start to tell it, okay, this can move this way, this cannot move this way. And a fasten is kind of like gluing it together. So a fasten mate is completely rigid. You can see the description says it removes all degrees of freedom. And I'm going to fasten the first block to the origin of the assembly. And you can imagine that's kind of equivalent to gluing it in place to the origin. It serves the same function as fixing it, but now it's also fixed in a location relative to the assembly's origin. So without further ado, that's the fasten. It opens up a window and it asks for mate connectors. So a mate connector can be any part or feature that's in your workspace. The first connector I want is the origin. And so this might start to be a bit of a lot to take in. You can see a mate connector has a bit more three-dimensionality than what we've had so far. This is kind of where these axes start to come into play. You can see once I hover over the origin, I have these three options and I have this little circle. So the circle kind of tells you which way this mate connector is facing. Let's say I just want to face up. So if I put my cursor first over the point, the origin, and then I move it up a bit, I'll have the connector that I want. So once I have a shape that looks like this with that little circle pointing up, I click once, you can see this like faint outline of what's happening. And the other mate connector that I want, let's say, is one of these bottom corners of my brick. And so since this mate connector is facing up, I kind of want my mate connector here to be facing in the same direction. So when you work with these, there's going to be a lot of rotating, a lot of zooming. What I ultimately want is to select this corner point, the bottom corner of the brick, such that the circle is kind of facing in the up and down direction. Yeah, I'll do that again. It's with Onshape, every CAD program does this a bit differently. Onshape is kind of similar to Fusion 360 in how it handles these, but it's a bit awkward in my opinion. But so let me just get rid of that mate connector. When you first click fasten, you'll get something like this. And the first thing you want to do is select the origin. And I want my mate connector to kind of face up and down in the Z direction, which you can see in this navigation cube. Z is this way. So once I hover over this origin, I have 3 options for directions. 3 options. Right, 3. And I want to pick the one in Z, which is this one. And I'll click. For the second one, I want to select a corner of this brick. And so it's a bit picky about how you have to kind of get to it. What I know is that this bottom, this thin walled face here, that's kind of what I want to be lying flat on the ground. And so if I start by putting my cursor, kind of zooming in, if I put my cursor around on this surface, it kind of lets me snap onto this corner that I want. So once I do that, I can just click on it. And you can see what happens is that this origin and that point on the brick that I just selected will now be aligned such that those mate connectors that I clicked are kind of with each other. So I could click check mark here, and then I cannot move it around anymore. It's just like I fixed it, but now the origin is set on the brick. I know probably not everyone got that. I will show that one more time, a bit differently. So I just deleted it. Everything's free again. I start off with my fasten mate, which brings up this window. And I start off, but I'll be a bit more haphazard this time because you can be, and it's still going to work. And I just want to demonstrate that it's possible. Let's say I just carelessly kind of like click whatever. That's my first mate connector. Okay, and here I just kind of click this point. Okay, in that case, I guess I was too accurate, but let's say that you get something weird that looks like this. You can actually change the way the mate connectors are oriented. And the way is to do with these tools. So this one you might recognize from when we were doing extrusions. It's flipping the direction. So right now, this brick is upside down. So I can flip it over the primary axis. You can kind of see what that does. It kind of flips it upside down, right side up. The second option I have is to flip the secondary axis. And you can see what that does is kind of, now it's rotating around. So what I really want is for everything to go in like the positive X, Y, Z direction. So I can just keep clicking these until I get what I want. Which is that. So now hopefully you're at the point where this block is locked and everything else is still free to move. But that is your first mate. You fastened the block to the origin so that it's now fixed in place next to some reference point that you know. All right, if there are any questions, please ask. If not, we will go into the next mates. All right, great. So next thing we'll do, I'm going to start stacking bricks on top of this brick. And again, that's all with the fastened mate. So I start a new one. It asks me for mate connectors again. And I have a lot of choices on what I can choose. Let's say my goal right now is to place this block on top of this block such that they're like aligned with each other. All 8 of the studs are on top of each other. So when the brick is in that condition, what I know is that this corner will kind of be touching this corner. And so since I know that, I can just kind of select the corner, select this corner, and OnShape will resolve the mate. And you'll have something like this. If you had any issues with that, feel free to ask, but I'll kind of move forward now. Let's say now I don't want to just have them straight on top of each other. Maybe I want one to go out a bit. I can keep doing that with the fasten mate. And I have to get a bit clever this time. I know that if I want to place this block, maybe so it's these 4 studs overlap these 4 studs, I know that this corner here will kind of go onto the middle of this block here. So just to show what I mean, let's say I select this corner, and I go up here, and I can select this point. It's kind of halfway here. And doing that, I can accept it. Similarly for the other one, maybe I want to put it out on this side. So I select the corner that I want. And the corresponding corner, and I can accept it. Yeah, so I'll show that last one more time. I may have gone a bit fast. I deleted that fasten, so this one is free to move again. And so everything I've done so far is just with this first mate, the fasten mate, which I described kind of like a glue. So if I were gluing these Legos together, I would do it such that this corner touches this corner. And it's not that anything special about those corners. I just know that when this brick is in the right position, these corners will overlap just based on how it is. So I start off, I take that corner and I go down here and I take the corner that I want here. Once I do that, it kind of moves it into place. And if I look at this and this is what I want, maybe for some reason it does something weird like that, like that. What I can do is just click these 2 sets of arrows until it gives me what I want. If you're ever assembling anything and you keep clicking these arrows, but it never gets quite what you want, you might just want to restart the mate. Maybe you selected the wrong thing as your connectors. But in general, you should be able to fix things with these tools. So once you accept that, you'll have something a bit like this. All right, before we go into the next mates, there is a bit of a sidetrack kind of topic I want to talk about. So if you have any questions about the fasten mate so far, or this assembly workspace, please ask. All right, someone wants to go over the last brick, so I'll just do that one more time. If you ever have like a issue with a mate that you just can't figure out, it's often easier to just start over. So we start with a fresh mate, we have a fasten, we want our mate connectors. I know the first one is going to be this bottom right corner. So I can just select that. And now I notice that it's kind of facing out this time, which is completely fine. I can just select the point on the rest of the work that I want that point to go. And I select it. Okay, great. So now you've kind of seen like the full stack, so to speak. You have at least a basic understanding of everything you need to model pretty much anything you want. You know how to make a sketch. You can turn that into a 3D part using your 3D tools. And now once you make multiple different parts, you know how to import them into an assembly and kind of make a more complex structure with them. So that's great. We will go over some of these other mate tools, but before we do that, I just want to show you a very useful function, which is the ability to import things into Onshape. And so since you all are working on a practical project with hardware, which is your robot certainly has like screws and bolts and nuts and standard parts that can be bought off the shelf. And that's true of like almost every project where you're going to use off-the-shelf components. And so these components, you're going to buy them from somewhere, right? And that somewhere might have a part catalog. So as an example, I'll just go over this very common one. So this one's called McMaster Car. You can just go to mcmastercar.com or mcmaster.com. This one is very commonly used in like the engineering teams at my school and college, where we have like various teams that make whatever. And it's because hardware is standardized. So let's say, for example, that we want a screw. Well, if every person who makes screws makes a different kind of screw, I will copy the link. There, it's in the chat. So if every screw manufacturer in the world, if every fastener manufacturer in the world just made their own thing, however they liked, then if you bought things or designed things to use one company's screws, you couldn't use ones that were made by another company, which is terrible. And so in reality, there are standards for everything, so that no matter who you buy hardware from, it'll always fit with your parts. And most of you have probably run into this by now, just working with robots, since you're using standard hardware that makes things fit. So you might not use McMaster, but you probably use some other catalog. I know like Rev Robotics. I personally was not on a robotics team, but this is just one that I found while browsing. Rev Robotics also has like a catalog where you have parts. This is not an advertisement. I forget what it's called. Like I think you might use like Builda or something. Go Builda. Yeah, so these websites usually have part catalogs, which are kind of like this, where you can go in and select things that you want. I'd better charge my laptop. All right, so not to stay on this too long, let's say that I need a screw for my robot, right? So I want a socket head of some kind, just alloy steel, whatever is fine. And so as you start designing things, you're almost certainly going to need to integrate these fasteners, most likely some kind of bolt or screw. And the question is, first, how do you pick one, and how do you incorporate that into your CAD model? I won't go too much into how to pick one. Hopefully, either you have some that you standardize on your robot, or you'll buy some for your specific system. Let's say that I just want quarter 20. So you can see every thread you want, every diameter, every length is going to have its own like product serial number. This is true on pretty much every catalog you'll go to. And what's great about McMaster and a lot of these catalogs is that they provide CAD models. This is really short. How about this one? That's extremely long, but and so McMaster at least provides a lot of CAD models. I see someone posted a link in the chat. I'm kind of curious, so I'll click on it. Yeah, so this is great. I think this also includes CAD models, so great, thanks for posting that. I guess maybe I should demonstrate with that, but since I'm here, there are various kinds of like file formats. STEP is probably the one you want. STEP is most commonly used and is most likely to work no matter what CAD system the other person is using. So what you can do is download the file. You can save it just like any other file. I'll just put it in my downloads. And now that I put this screw into my computer, basically, what I can do is go here, hit the plus sign, and import. And if I go to the folder where I saved that file, you can see that socket head screw appears here. And it gives me a few options. I can just import it. It also gives me this option to combine. This only really matters when you have a complex step file with multiple different parts. Onshape can integrate those into a single part for you if you want. In this case, it doesn't matter at all since it's just a bolt. Someone asks how to download. I'll go over that before I go too far off. For McMaster, if you kind of scroll down, maybe I'll just, let's say I want a nut now. Hex nut, medium strength, grade 5, fine. Quarter 20. So assuming that it has this like little CAD icon, that means it has a CAD available. And what I can do is just select the file format that I want, which is STEP, and hit download. So it's just like any other download. I'm not too familiar with this. It seems like it's sponsored by the company that makes SolidWorks, Dassault Systems, French name. It's pretty cool. I think here you can just download it. Let's say I want this clamp. Yeah, I think I can just, well, for this, it seems like I have to log in. I do have a Dassault account, I think, but I'm sure if you're using this, you probably have an account. So just download it. Once you have the file, you go to the plus sign, you hit import, you select the file you want. You can leave this just as a default. Likewise with these, you can just leave them as default and you hit OK. It'll often take like several seconds for it to show up, so just be patient. Still going. You can see a new folder was created with the imports, but usually you don't need to worry about that. And once it uploads, you can see that now I have this socket head screw, and it's fully modeled, threads and all, socket head. I can do with it as I wish. If I go to the assembly, I can insert this screw, and now I can put it into my model. And the takeaway here is that you should almost never model these standard hardware. If you're spending time trying to model a screw, unless it's for like an exercise to learn to be better at modeling things, it's usually like a waste of time to model screws and nuts and bearings and seals and all your standard stuff that you find on your robot. Yeah, someone asked if there's a singular ball bearing. You know, that's not as ridiculous as you might think, because ball bearing standards are very precise and usually not like a simple number, you know, like depending on what the bearing's for, maybe it's like a part of a constant velocity joint. Those diameters are actually very important. And so, yeah, I understand. So like even for like a single joint, the ball bearing inside might be like some very precise, very strange diameter. And so instead of trying to like figure that out from data sheets to model a sphere, you'd just download the entire CV joint off of wherever you're getting it from, hopefully, and that's how you do it. Also, McMaster has pretty much everything. I guess in this case, they don't, oh, they do provide a CAD model. Yeah, that's pretty cool. So to answer your question, yes, you can just download a single bearing ball. I see some of you may have picked some very small screws. Yeah, lots of crazy stuff on McMaster. It's worth a look. If you ever need to work on like your own project, it's worth taking a look, though oftentimes it is a bit overpriced, just cost of convenience. Someone has a question about how I downloaded it, so just one more time, I'll pick something a bit more interesting, maybe a shaft collar. So you navigate on whatever website you want. I know someone linked this website, which looks pretty great. If you're able to download things from here, go for it. I'll just stay on McMaster. So I navigate to a part that I want and make sure it has this CAD icon. If it does, I can go to product detail. This is a really weird shaft collar. And I can download it. Save the file, download as you usually would a file. And when you go to Onshape, if you hit the plus sign, it gives you the option to import. So let me see if I have some. Earlier this year, I downloaded some gears. So it'll open up this window. You just hit OK. You have to wait for a minute as it kind of uploads your file. But once it does that, there it is. Easy as that. So I know someone showed me earlier, like they were trying to CAD a U channel. And so I told them that there was another easier way to do it. And the easier way would be to find the exact U channel that you're working with, which almost certainly is out there. And if there is a CAD model, just download that exact part, because that is what you're working with. Like there's no reason to try to guess the dimensions and all that when you have exactly nominal to specification, the model by the manufacturer. So if you can find it, use it. It'll make your model more accurate. It'll save you time. It's just good. Yeah, so in the remaining 15 or so minutes that we have together, I'll go over some of these other assembly tools. Let's see. I have a few ideas about what I could do. I guess if we're trying to finish something this class, I might go for something a bit simple. So let's create a new part studio, go to the plus sign, make a part studio. And let's try making like a little simple wheeled toy car, right? I'll make it extremely simple since we don't have much time. Start with a sketch. Hopefully you're all pros at this now. Make a rectangle. I can dimension it to the size that I desire. It's a bit short. Not too important. While we're here, I will show you an additional few tools, just so you have more practice with them. So I'll go back into my sketch. Don't finish it quite yet. I'll show you two new tools. One of them is a sketch tool. It's the point. And so each of these are points. Like every little dot on your screen is a point, and you can actually explicitly create points. right now we've kind of implicitly created them by defining other features that have points in them. But if I just want a point, I can make a point using this tool. So I click, click. This is kind of where I want to put my wheel axles eventually. And so for these 2 points, since they're kind of wheels on my little toy car, I want them to be horizontal. Use the horizontal constraint. I'll define dimensions in the same way that I did before. I can just select pairs of points and add dimensions until it turns black. So this is what I'm trying to do, just a rectangle with these points on them. Having done that, I'll accept my sketch and I'll extrude into the page backwards, maybe another 4 inches. Sure, that looks fine. So here we go. This is my car. Very nice. Now I want to see those points that I defined. So I'll show the sketch again. I can reveal it using the eye. And now I can see these points. So I can use these. So here's the second tool that I'm going to show you, just to leave off. It's called the hole tool. And you can remember last week when we made our gasket, we kind of defined these holes in the sketch itself by drawing circles. What we're going to do now is define points where we want the center of the hole to be. And we'll use the hole tool to kind of define the rest of the tool or the hole. So those of you who are familiar with your screw and bolt, like standard thread drill and tap size charts, sorry. If you're familiar with like drilling and tapping, you'll know what these all mean. If you're not, don't worry about it. Just ask what kind of screw you're using and match it up. Most likely you're going to use like a, well, assuming you're not using metric hardware, if you're using like inches, imperial standard, you're probably using ANSI. And so clearance, the other options are tapped and drilled. That probably won't affect you unless you're manufacturing it yourself. Size, 1/4 inch, automatically tells you what diameter this should be. And the main thing to worry about is this thing, where you just select points. And once you do that, you select these points. You'll notice I just left these all on the defaults, which you can do as well. It'll create a hole in your part where those points were. And that's really handy. I don't have to model these circles in my sketch. And I don't have to go look at a tap chart to know exactly what diameter to make them. All I did was I made those points in the sketch, and then I used the hole tool, which has its own like dictionary of how big certain holes are. So if I want an ANSI 1/4 inch clearance hole, that's 0.257 inches. I select the points, I accept it, and the holes appear. So these will be the axles of my little car. You can see the hole goes through. And I'll hide my sketch again just because I don't want to look at it. I'll name my part studio just to show you that I can. I'm going to just type body. Great. And now we'll just make the wheels. So I'll create a new part studio using the plus sign. And there's a few ways I could go about this. For now, I'll just CAD the wheel. So there's not going to be an axle. The wheels will kind of be floating, and that's fine. In real life, you'd probably model each part in your system, but the main objective right now is to demonstrate a few more mates. So to do that, I'll sketch a single circle, and I'll put a point at the center. I guess I don't need to. Do I need to? I guess I can't, so there you go. I make a circle at the center of my sketch, and I'll give it some dimensions, maybe a couple inches, and that's that. I'll extrude it to make the wheel, maybe a 1/4 inch thick. And finally, like I did before, I'll just use my hole tool. Hopefully it lets me select the origin, which it does not. So I'll just have to, let me see, I don't believe that I can't make a sketch here. I'm going back into my original sketch. I feel like I should be able to make a point. If I can't, I guess what I can do is, like I said, use my construction lines. So I can automatically create these constraints just by hovering in the right place. You can see the lines turn black. Then I can kind of use this construction tool, which I showed you before. And it's kind of an example of where you might use it. So now this point in the middle here is kind of defined by these construction lines. So hopefully, I may not have needed to do that. Well, I've done it, so in any case, make sure you reveal the sketch. I think that was a problem before. If you reveal the sketch, you should be able to select the origin, regardless of whether or not you have these construction lines. You want to make a hole, select the origin, have it be the same dimensions. Yes, I'll go through this a bit quickly. If you can't follow along, just try to keep track of the main points, which is what I'll demonstrate in the new assembly. So create an assembly, blank workspace, nothing in it. I insert my car body, and I want 4 wheels, which I can add just like I did with the bricks. Click the check mark. And here's where we get the first new tool, and that's the Revolute Mate. So the Revolute Mate kind of adds a degree of freedom. As you can kind of guess for the name, it lets things revolve around a certain point. And so right now, this car is not going to have an axle. So the wheels will be kind of floating, but you can imagine if I had more time, if I really cared about this thing, I would make an axle as well, but the mates will still work without an axle, which is the great thing. Like a lot of the time, you might not include all the bolts and hardware in your CAD, especially if it's like a preliminary design, but you'll still be able to mate things together. So I selected my Revolute Mate, and I'm starting to pick out these connectors that I want. So in my case, I'll show that one more time. Revolute. I select the center, the axis center of this wheel, and I select the corresponding kind of axle hole in the car, and that is the mate. So you can see now, I guess it's a bit hard to tell. Let me fix the body of the car so it can't move around. And now, you really can't see because the wheel is completely symmetric, but I can spin it around. Maybe if I animate it, it'll be easier to tell. Okay, if you look really closely, due to the fact that Onshape's rendering is not perfectly circular, hopefully you can see that the thing is indeed spinning around. So the Fasten and Revolute mates, those are the very important ones that you'll use all the time. You can imagine I do that with the rest of the wheels. There are a few other ones. There's the slider. You might use that if you're trying to model like a piston and cylinder. Planar mate, this one I can demonstrate. If you just want 2 surfaces to be touching each other, kind of moving on top like a hockey puck on ice, that's the planar mate. There's the cylindrical mate, which is like Revolute, except it allows me also to move axially in and out. I'll show that one. So move this out of the way. The difference between these two is that this one can not only rotate, but also move in and out of its axis, like so. There's a bunch more. Most of them you probably won't use unless you're working, I guess, with a drivetrain or something. You'll note that I have options for patterning. It's very powerful, but this hopefully gives you a glimpse into what's possible to do in Onshape, and hopefully gives you some ideas for whatever you're working on right now for the team. And with that, we're almost at the end of the class. It's 8:28. So if you have any last questions, please ask. But otherwise, that is all I have for you. Hopefully you enjoyed this quick crash course on Onshape and CAD. And have a good evening. I guess I'll still take questions if you have them.